Hello, the topic of my presentation is evaluation and implement of the email spam filter, which presented by Kaidi Xu. So, when we talk about the spam filter, there is the investigation that more than 70% of the emails are unwanted message or spam. So here, this is the some common types of filters, which treat encoding messages according to the previously learned knowledge about of the sender. So in my report, the important point is the base and the SVM. So let's start from the base spam filter. Here, the PSW means the PR happened when the possibility of the S happened when the W happened. So we can see here this is definition by this formula. The PSW is the probability that a message is a spam, knowing that a word replica is in it. So let's suppose the message contains the word replica. Most people who are used to receiving email knows that the message is likely to be a spam. More precisely, a proposal to sell counterfeit copies of well-known brands of watches. So the spam detection software, however, doesn't know no such fields, and all it can do is compute probabilities. So the formula used by software determine that it is the Bayes theorem. So in my report, we will use this formula to conduct an algorithm. Here is the advantages. The spam that a user receives is often related to the online user activities. For example, a user may have been subscribed to an online newsletter that the user considered to be spam. This online newsletter is likely to contain words that are common to all newsletters, such as the name of the newsletter and its originating email address. So a Bayes spam filter will eventually assign a high probability based on the user-specific partners. So the legitimate emails a user receives will tend to be different. For example, in a corporate environment, the company name and the names of the clients or customers will be mentioned often. The filter will assign a low spam probability to email containing these names, of course. So the word probabilities are unique to each user and can evolve over time with corrective training whenever the filter incorrectly classifies as an email. As a result, Bayes spam filter accuracy after training is often superior to predefined rules, and it can perform particularly well in avoiding false positive, where the legitimate email is incorrect classified as spam. So, for example, if the email contains the word which is frequently used in advanced fee phrase spam, the predefined rules filter might reject it outright. A Bayes filter would mark the word as a probable spam word, but it would take into account other important words that usually indicate legitimate email. For example, the name of his wife indicate the email is definitely not a spam, so which could overcome the use of some sensitive word. Here is the disadvantages. We can see, depending on the implementation, the Bayes spam filter may be susceptible to Bayes poisoning, a technique used by spammers in an attempt to degrade the effectiveness of spam filter that rely on Bayes filtering. A spam practicing Bayes poisoner will send out email with large amount of legitimate text. Spammer tactics include the insertion of random innocuous words that are not normally associated with spam, thereby decreasing the email spam score, making it more likely to put a base spam filter. However, that is not only the most significant probability are used, so that padding the text are with non-spam related words does not affect the detection probability significantly. Words that normally appear in large quantities in spam may also be transferred by spammers. I think this is really harmful to the base spam filter. For example, the vigor, this word would be replaced with this one or this one. So in the spam message, the recipient of the message can still read the change word, but each of these words is met more rarely by the base filter, which hinders in learning process. So as general rule, this spam technique doesn't not work very well, because the derived word end up recognized by filter just like the normal ones. Another technique used to try defeat base spam filter is to replace text with picture, either directly included or linked. The whole text or message or small part of it is replaced with the picture where some text is drawn. The spam filter is usually unable to analyze this picture, which would contain any sensitive words. However, since many mail clients disable the display of linked picture or security reasons, the spam sending links is distant picture might reach fewer targets. Although a picture size base is definitely bigger than the test size, so the spam need more bandwidth to send message directly include pictures. Some filters are more inclined to decide that a message is spam if it has mostly graphic contents. A solution used by Google Init Gmail email system is perform an OCR on every mid to large size image, analyzes the text inside it. So here is something about the TF-IDF. The weight of factor used in information and text meaning. It represents a numeric statistic which rejects how important a word is to do a document in a collection or corpus. The TF means the term frequency, is a value that represents how often a particular word appears in a document. The more frequent the value of the word is, the more important it is in the document. However, if the word appears too frequently in the corpus, this means that the word is too common in the corpus. For example, the, is, are could be a keyword because it does not because it could not be a keyword because it's too common. The situation can be adjusted by IDF, which is inverse document frequency. DF can be obtained by dividing the total number documents by the number of documents containing the term. IDF is the inverse value of DF, and TF-IDF is the product of two statistics. TF and IDF, high weight in TF-IDF is reached by a high term frequency and the low document frequency of the term in the whole collection of documents. Hence, the weights tend to filter out commenters. The TF-IDF can be successfully used for stop words filtering in various subject fields, including the text summarization and classification. So, here's the algorithm we used in the project. We can see we used the score M and threshold N to judge an email whether an harm or spam. If the score M greater than N, the email will be supposed to be a spam. If not, it will be a harm. The value N will be generated by training number samples, which will be shown in the experiment 6 section. So the experiment is here. We can see the dataset we use. We training emails in 5,000 contains 1,000 harm emails and 4,000 spam emails. Their emails are already labeled by manually. This process will make our program to learn how to judge the harm and spam. So when in the test section, after training, in order to test our algorithm, we used a texting dataset which is made up of 715 spam email and 115 harm emails. Here is the environment of the experiment. So let me show you now. Here is the training section. We can see here. First, we can use the first training. Now, look, we have already trained the 900 message, and we let the program know the 115 is harm and the 700 of 15 is spam. So in the test section, we can see here, by the iterator of the algorithm, eventually it can classification the 142 emails are harm and 700 of 58 are spam. So we can see here the result is very good. After the iterated by the algorithm, it eventually shows that for the totally 900 emails, the precision of detecting spam is highly to 99%, which is high enough to people using daily life. So, summary of the conclusion. Here, we can see the evaluated the test classification and implement of the spam filter using Java libraries and base, and that we have already done, and this really shows the high precision and accuracy results. But the filter algorithm used to contain a deeper study improve the filtration accuracy. And the next step, we want to add audio, video, pictures, and other filtering capabilities. Do not limit it to the mail test filtering. That may be we should use the test recognition in picture or video. Okay, that's all. Thank you.